Welcome to Developer Roadmaps. Every single time you visit a website, there's this incredibly complex, super high-speed dance that happens behind the scenes. Today, we're going to pull back the curtain on the three core protocols that run that dance: DNS, HTTP, and SSH. Seriously, understanding these is fundamental for any developer. So, let's get right into it. So you type a URL into your browser and hit enter. A page just appears, right? It seems so simple, but what's really going on in those few milliseconds? Well, for a developer, knowing that is absolutely crucial. So that's what we're going to do. We're going to follow a single request, step by step, from your browser all the way to the server and back again. Okay, so first things first. Before your browser can even think about asking for a web page, it needs to know where to send the request, right? It needs an address. And that's exactly where our first protocol, DNS, comes into the picture. The best way to think about DNS is to picture it as the internet's giant phone book. It's really that simple. See, we humans are good with names, like developerroadmaps.com, but computers, they talk in numbers, specifically IP addresses. So DNS is that critical middleman. Its whole job is to look up the name you type in and find the correct number, so your browser knows exactly which server to call. And believe it or not, this lookup process is like a lightning-fast four-step relay race. It all kicks off when your browser asks something called a recursive resolver, usually from your internet provider. That resolver then asks a root server, which doesn't know the answer, but it knows who to ask next. It points to the right TLD server, the one for .com or .org. That TLD server then points to the final source of truth, the authoritative server. That's the server that holds the actual IP address and sends it all the way back. And the crazy part? This whole chain reaction happens in just a few milliseconds. So if that sounds like a lot of steps, well, it is. But here's the clever part. It doesn't have to happen every single time. And this is why your favorite websites load so much faster the second time you visit. Your browser, your computer's operating system, even those resolvers, they all keep a temporary memory, a cache, of recent lookups. So the next time you go to that site, they just say, oh, I know this one, and grab the IP address right from the cache, skipping that whole journey. All right, so we've got the IP address, DNS did its job, and we now know exactly where the server lives. So what's next? Well, now it's time to actually ask for the web page. And that is the job of our second protocol, HTTP. Really, the easiest way to get your head around HTTP is to think of it as a simple conversation. On one side, you have your browser, the client. It sends an HTTP request, which is basically it saying, hey, can I please get the file for the main page? On the other side, you have the website server. It replies with an HTTP response, which says, sure, here's the HTML code you asked for. That's it. This fundamental back and forth, this request and response cycle is literally what builds the entire web. But that conversation has gotten way more efficient over the years. Back in '96, the early web ran on HTTP/1.0, and it was painfully slow. Why? Because it had to open a brand new connection for every single file on a page. HTTP/1.1 came along and made things better with persistent connections, but you could still only download one thing at a time. The real game changer was HTTP/2 in 2015. It was a total redesign, built from the ground up for the kind of speed and complexity we expect from modern websites. And this right here is the single biggest upgrade. With the old HTTP/1.1, you had this problem called head-of-line blocking. Imagine you're in line at a grocery store, and the person in front of you has a huge, complicated order. Everyone else has to wait. That's what happened on the web. A big image would block all the smaller files behind it. HTTP/2 fixed this with something called multiplexing. Now, multiple requests and responses can happen at the same time over one connection. It's literally like turning a single-lane country road into a 6-lane highway. Nothing gets blocked. This one change was huge, and it completely changed how we built fast websites. Okay, so we've seen the whole process from the user side, how you get the web page. But let's switch gears for a second. What about the developers who actually build and maintain that server? They're not physically sitting in a data center next to the machine. They need to connect to it remotely and, most importantly, securely. And for that, they use our third protocol, SSH. SSH stands for Secure Shell, and it's the protocol that lets a developer securely log into a server from anywhere in the world and get access to its command line. Think of it like this. It's a completely encrypted tunnel that gives you a direct terminal to that machine, as if you were sitting right in front of it. This gives them total control to configure things, run updates, and fix problems. So how is it so secure? Well, the magic behind SSH is this really clever system using what's called a key pair.
Imagine you have a special kind of lock. That's your public key. You can make as many copies of this lock as you want and put one on every server you need to access. It's totally safe to share it. But here's the catch. There's only one private key in the whole world that can unlock it, and you keep that key's secret safe on your own computer. And what this system allows for is incredibly secure, passwordless authentication. It's a pretty straightforward three-step process. First, on your own machine, you generate your key pair. Second, you copy your public key, the lock, over to the server. And that's it. From that moment on, whenever you try to connect, the server uses that lock to verify it's really you. No password needed. And this is exactly why it's considered a major security best practice. Once you have keys set up, you can disable password logins completely. And by doing that, you just eliminated the risk of someone trying to guess your password over and over again. That's a brute force attack. It's simple. If an attacker doesn't have your secret private key, there is no way they're getting in.
So there you have it. We've followed the entire journey. We saw how DNS finds the address, how HTTP fetches the page, and finally, how SSH lets us securely manage the server that sent it all. So let's wrap this up and mark this as a really important checkpoint on your developer journey. So here's the entire trip in a nutshell. You've got DNS, the phone book, which finds the server's IP address. You've got HTTP, the conversation, which requests and receives the website data. And you've got SSH, the secure key, which lets developers manage the server. 3 distinct protocols, and each one plays an absolutely critical role. Look, understanding how these pieces fit together isn't just trivia. It's a foundational skill for any developer. It's like knowing about the plumbing of the internet. So let's go ahead and place this on our roadmap. This is a completed and totally essential checkpoint. Of course, the journey of a request actually goes even deeper than this. We didn't even talk about the layers of TCP/IP, or routers, or switches. But now that you see how all these high-level pieces connect, it makes you wonder, what part of the internet stack will you explore next? This is Developer Roadmaps. Map your path, build your career.